Imagine looking into a mirror, not one that shows your reflection, but one that bends time itself. A mirror not crafted from glass, but from polished gold. Its surface curved with impossible precision, able to catch the faintest echoes of creation. And when you gaze into it, you don't see your face. You don't see your world. You see the universe as it was billions of years before human eyes ever existed. A time when stars were new, when light was young, and when space itself was still learning to expand. That mirror is the James Webb Space Telescope. Built not to look outward, but backward, into the origin of everything. But what it found there wasn't what anyone expected. It didn't see a quiet, newborn universe filled with scattered dust and chaos. It saw structure. It saw order. It saw impossibility. The discovery that broke time for generations. Scientists thought they understood how the cosmos grew. The Big Bang. A long, dark silence. Then the first light, stars forming from clouds of gas, merging over eons into galaxies. The deeper you looked, the simpler things were supposed to get. But when Webb focused its golden mirrors on a tiny, supposedly empty corner of space, it saw something that shouldn't have existed. A galaxy. Not a hazy smear of light, but a fully formed spiral, glowing with mature stars and wrapped around a massive black hole at its center. A structure so advanced that it looked like it had lived for billions of years, yet it appeared only a few 100 million years after the Big Bang. It was as if the universe had skipped its own childhood. And then came more. Dozens of galaxies, brilliant, organized, chemically complex, appearing far too soon. Each one defying the rules of cosmic evolution. Astronomers stared at the data in disbelief. What if the timeline was wrong? What if our entire model of cosmic growth, gravity, star formation, even time itself, was missing something fundamental? Galaxies that shouldn't exist in theory, early galaxies were supposed to be crude. Simple clouds of gas collapsing slowly under gravity, gradually forming stars over billions of years. But Webb's images told another story, a cosmic sprint rather than a crawl. These galaxies were bright, stable, and astonishingly massive. Their stars had already fused heavier elements, oxygen, carbon, even iron, the chemical fingerprints of generations of stellar death and rebirth. But that process takes time, a lot of it. Yet here they were, ancient chemistry in a universe still in its infancy. It was like planting a seed and finding a full-grown forest overnight. And at the center of one of these galaxies lay something even stranger, a supermassive black hole, a billion times heavier than the Sun. Such giants take eons to form, feeding slowly over cosmic history. But this one had appeared almost immediately after the dawn of time. No current model can explain that. Some scientists suggest it didn't form from collapsing stars at all, but directly from the collapse of dense energy regions right after the Big Bang. Others whisper that dark matter may have accelerated its growth, or that we're witnessing a new kind of cosmic physics. Whatever the cause, Webb had exposed a crack in reality, a point where science meets something stranger. A hidden geometry. As astronomers analyzed the data, a pattern began to emerge. These galaxies weren't randomly scattered. Their positions and shapes seemed to echo a mathematical rhythm. Ratios found in nature, like the golden spiral seen in seashells, hurricanes, and galaxies themselves. Was it coincidence? Or was it a sign of an underlying geometry, a cosmic design coded into spacetime? Everywhere Webb looked, it found echoes of order within chaos. Fractal structures repeating across scales, like the universe was painting itself with the same brush again and again. The seeds of life, older than time. And then Webb found something even more profound, not inside stars or planets, but drifting in the empty dark between them. Faint traces of complex organic molecules, the carbon-based scaffolds that form amino acids, the ingredients of life. They weren't trapped in comets or asteroids. They were floating freely across intergalactic space, carried by light older than Earth itself. This meant that the chemistry for life wasn't rare. It didn't need warm oceans or gentle sunlight to begin. It was written into the universe almost from the start, a biological signature embedded in the cosmic code. Life, it seemed, wasn't an accident. It was a pattern, a consequence of how the universe builds itself. Then came one image that silenced even the skeptics. A pattern so symmetrical, so deliberate, it felt almost impossible. 6 galaxies arranged like petals around a glowing central core, perfectly spaced, rotating together in eerie synchronization. Astronomers named it the cosmic flower. At first, they thought it had to be an illusion, a trick of gravity. Perhaps a distant light bent and mirrored by a massive object between us and it, a phenomenon known as gravitational lensing. But the more data the James Webb Space Telescope collected, the less sense that explanation made. Each petal was a galaxy of its own, complete with billions of stars and its own dark matter halo. Each one moved with uncanny coordination, as though responding to a hidden rhythm in space. Computer models tried to recreate it, simulating cosmic collisions, ancient mergers, turbulence from early cosmic filaments, yet none produced this degree of precision. There was no sign of random chaos, only harmony. And that harmony carried meaning. Could it truly be nature's coincidence? Or was it something else, a structure deliberately arranged, a cosmic symbol left to be discovered only when a civilization developed eyes sharp enough to notice? The idea seemed absurd, and yet, the image existed. Like a flower carved in light, waiting 13 billion years to bloom before the gaze of a single species. The observer's paradox, that discovery led to a question even more profound than the image itself. What if our act of observation changes what we see? Quantum physics has long suggested that the universe behaves differently when observed. Particles that act like waves suddenly collapse into fixed states when measured. Reality, at its smallest scale, appears to respond to awareness. But what if that same principle applies not just to atoms, but to galaxies, to space, even to time itself? Some of Webb's deep field images showed strange, shifting anomalies. Subtle differences between exposures taken days apart, faint arcs of light bending slightly, luminous knots appearing or fading as if the cosmos were breathing under scrutiny. Engineers called it data noise, calibration errors, interference. But a few theoretical physicists dared to wonder if something else was at work, a feedback loop between observer and observed. What if the universe, on some incomprehensible level, knows when it's being watched? What if by building Webb, we didn't just peer into the past, we invited the cosmos to recognize itself through us? A mirror that doesn't just reflect light but awareness. If observation shapes particles, perhaps it also shapes galaxies. Perhaps consciousness and cosmos are not separate things, but two sides of the same mirror, one looking into the other, each defining the other's existence. The mirror that remembers. The James Webb Space Telescope was built to study ancient light, to trace the faint glow of the first stars that ever shone. But what it found may be something deeper, a reflection of existence itself. It has shown us galaxies far too old for their time, black holes impossibly massive when the universe was still young, and chemical fingerprints suggesting that the seeds of life were sown almost as soon as creation began. Each of these discoveries challenges the cosmic timeline we thought we understood. Each forces us to question whether the universe is not a random sequence of accidents, but a story with memory, intention, and rhythm. Every photon Webb collects is a message from the past, a whisper that has traveled across billions of years, only to arrive at the one place where it could be understood. And in decoding that light, we do more than observe the universe, we participate in it. Because maybe what Webb reveals is not just what was, but what is becoming. Maybe the act of looking back is also the act of calling forth. Perhaps creation is still unfolding, not out there, but through us. When we stare into Webb's golden mirrors, we are not looking into emptiness. We are looking into the memory of the universe, a memory that, in that moment, remembers us. Maybe we didn't find the edge of the universe at all. Maybe we found its reflection. And when we looked through that ancient light, the universe looked back, and knew that it had finally been seen.